Okay, this is today's assignment from 14.2. We're going to be talking about creating graphs of trig functions that have shifts, specifically a horizontal shift and occasionally a vertical shift. Also, occasionally we'll see a negative sign that'll tell us we've got to do things upside down as part of a reflection. So to start out, we need to find the same two things we were finding last time, which would be the amplitude. In this case, it's 4, just the same as always. There's my amplitude. The next thing to find is the period. We know the period for a sine or cosine is always 2 pi over b. Well, in this case, b is the 1/3. You can think of it as 1/3 would distribute to give me 1/3 x. So this is 2 pi over 1/3. But I don't know how to divide by fractions, so instead I multiply by the reciprocal, which is 2 pi times 3 over 1, which gives me 6 pi. So my period is 6 pi. Very good. Next thing I need to find is what's called the horizontal shift. The horizontal shift is whatever makes the parentheses 0. And since this is x plus pi halves, I'm going to say that if x was negative pi halves, that it would make the parentheses 0, and that would take care of the horizontal shift. Last is the vertical shift, and vertical shift is always outside. If there's something added or subtracted, that'll be my vertical shift. In this case, there's none, so I'll put 0. Now what I need to be able to do is to produce the actual graph here. Get my baseline here, and this thing right here. Okay, let's extend that down just a little bit. Now, when it comes to actually doing this, the first thing I want to do is take care of my horizontal and vertical shifts before I worry about period or amplitude. I notice this shift is a pi half, so all my hash marks should be pi halves. I'm going to call this negative pi over 2, and I'm going to put in a dotted line to tell me that here is my new starting point. Okay, I'm no longer going to be starting at 0 like I have in the past. Instead, I will start here. Now, there was no vertical shift, and so I won't have to worry about that. One of my lines is off. There we go. All right. Makes me feel better. Okay, so now I have this. There's no vertical shift, so in essence, I could draw that same dotted line right on the axis. Okay, now that I have that, I want to figure out, I'm going to start here, I'm going to go through the motions, and I want to know where am I supposed to stop out here? What's the value where I stop? Well, to find that, I always add my period and my horizontal shift. So if I take negative pi over 2 and I add 6 pi, I would get, well, it's hard to do this without first converting this to pi halves. So I'm going to replace the 6 with a 12 over 2. 12 over 2 is 6, so this is 12 pi over 2. When I subtract 1 from it, I'll get 11 pi over 2. So I want to keep going along this line until I get to 11 pi halves. Well, this is 0, so first mark. Since that was pi halves, this is 1 pi half, 2 pi halves, 3 pi halves, 4, 5, 6, 7, 8, 9, 10, 11. This is 11 pi halves. And that's important because I know that when I start here, I'll go through a motion and I'll stop right here. But I started looking and I noticed there's way too many hash marks here. I can't possibly use all of these. I'm only supposed to have 4. Well, let's figure out how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 marks, but I only want 4. So that means I'm only going to use 4 out of the 12, means I have to get rid of 8 of them. Okay? So what I'm going to do is I'll start here and I'll get rid of the next 2. And then I'll keep this mark. Basically every third mark, because 3 times 4 is 12. So I'll remove this mark and keep this one. Remove this mark and this mark, keep this one. Remove this mark and this mark. Now I can go back and think, okay, well this is 1, 2, so this is pi. 3, 4, 5 pi over 2. 6, 7, 8 pi over 2. That's 4 pi. And then all the way out here, 7 or 8 would be 9, 10, and 11. Okay, so I could mark those in. I'm not going to kill you on having those marked in, but I'm going to get rid of my old marks that I no longer need. I only use them to get out to 11. Once I had that, I really only needed a certain number of them. All right, now this is a sine wave, and I know all sine waves start in the center of the axis, okay? They're going to go up to a height of 4, so I'm going to come up here. Let's make it tall. 4, negative 4. At the first mark, I'll have my amplitude, and then back to 0. Down here, I'll be at negative 4, and then back to 0. All that's left is to trace it out. And of course, this would go on in either direction forever. So there it is. The horizontal shift is always going to be the more complicated part. All right. Number 3 here, or number 28, we're doing a cosine function this time. Notice that it's negative, so it's going to be upside down. So instead of forming that W or U shape, it's going to form more of an N, or an M, sorry, something like that. And so we're going to deal with that. Let's start with our amplitude, would be 3. I know it's negative here, but the amplitude, the change in height, is actually 3. The period, think of the absolute value for amplitude. Period, okay, is always 2 pi over b. Well, this would have to be a 1. So this would be 2 pi over 1, which is 2 pi. Let's do horizontal first. Horizontal. I notice this is a minus pi, so the horizontal shift should be a positive pi. And then the vertical, it says plus 4, so I'm going to put a 4 down. Okay? And then let's go ahead and produce our graph. Whoops. We'll keep that maybe for later. Okay, and whoops, one more. Okay, I know that right off there's going to be a shift of pi. Okay, and so I'm going to come out here, I'm going to put pi right there. And this is where I'm going to put that dotted line. Okay, and I'll just set it right there. Okay, so I've got that vertical line there, and then I also need to know about the horizontal, or the vertical shift, which is up 4. So I'm actually going to 1, 2, 3, 4. I'm going to extend that line a little bit. Okay, and then I'll put in another dotted line going across at 4. All right, so I've set up my new axis of center, my new center area, but I have to deal with finding my ending point. I start here at pi. How far out do I go? Well, we always take the horizontal, which is pi, and I add it to the period, which is 2 pi, to get 3 pi. So if this is 1 pi, this would be 2 pi, and this would be 3 pi. But I don't have enough hash marks, so I can put one here and one here to get all 4 of my hash marks onto my graph. The next thing is the amplitude. Well, if I'm starting here, I need to go up 1, 2, 3. This would be as high as 7, and it would come down as low as 1. So I'm going to be between 7 and 1 the whole time. All right, cosine functions do not start in the center. They start at their amplitude. Normally I would start up here at 7, but since it's negative, it's going to be upside down. I'll start here at 1. I know at the next hash mark I should be here on the axis. The third hash mark I'd be up at my other amplitude, and then back and back. Alright, so it looks something like, whoops, something like this. And obviously, you know, I could continue this on and on, okay? But this is the curve that we're looking for. And I'll just clean that up real quick. All right, so there's my graph, my curve. Important things, I see that the minimum is 1, the maximum is 7. It has a period of 2 pi. It starts at pi and goes to 3 pi. May not seem like a huge deal, but you know, we need to know where we're starting, and that axis has a lot to do with it. Okay, the last one we want to look at is actually the tangent function from the set. And we're going to start with finding the period, which for tangent is always pi over b, so pi over 2, because it's 2x. To find the vertical asymptotes, okay, I find pi over 2b, which is pi over 4. 2 times 2 is 4. So next I need to find the horizontal shift, which I don't think for any of the tangent questions that I gave to you, you shouldn't have any horizontal graph. There's no parentheses here. And then finally we look at the vertical. Vertical should be down 3. Okay? And this is traditional version of tangent, meaning it'll look something like this. If it was negative, it would look something like this. So we're not going to do that. We're doing this, okay? Let's go ahead and produce our graph. We've got to get an x-axis. I'm killing myself with that. Okay, I need an x-axis, and I need a y-axis. Okay? And yeah. Okay, and then I need to do any shifting that takes place. It says that I have a vertical shift of -3. So I'm going to take my little guy here, stretch it out down here, and we're going to call this -3. 1, 2, 3. -3. And then we need to get in those hash marks and everything. With no horizontal shift, I can do the traditional 4, 1, 2, 3, 4, 1, 2, 3, 4, and call this pi halves. And this negative pi halves, obviously this would be negative pi over 4 and pi over 4, where I would have those vertical asymptotes. I'm going to use a different color. I just don't want to get confused thinking that I'm supposed to start somewhere. I know that can be the confusing part about this graph. Tangents are different. They behave differently. So in a lot of things, we see a lot of differences. Okay, so first off, instead of being centered here at 0, 0, I'm actually going to be centered down here now, because I've been shoved down 3 units. And since there is no negative in front of the tangent, I know it's a traditional tangent function, which means it'll look something like this. There's my tangent graph. Again, we can always go over and say, oh, it repeats. You don't need to, but it would repeat like this infinitely. Those are the 3 questions that I thought would be most useful to you. Hopefully it'll help you remember. If you don't know what you're doing, find these 4 pieces of information and we can talk about the graphs. But you've got to get those 4 pieces first. Good luck.